you had a question like that, like this, posed as find the current through RL, I highly recommend using Thevenin's theorem, and then if you have extra time, go back and use the mesh equations to verify your answer, or use voltage nodal, which brings me to the next and final point, voltage nodal. Okay, for voltage nodal, we're going to come up with our equations here for voltage nodal. How many equations are we going to do? Two, because we have 1, 2, and then 3 nodes. 3 minus 1 is 2. Okay? Now for the voltage nodal, remember it's nodal, so that means we have to look at a node. We're looking at a node, we're dealing with current. In this case, we'll have En sub 1 and En sub 2. For En sub 1, we'll have I1, we'll have IL, and I3. For En sub 2, we'll have that IL again, we'll have I2, and we'll have I4. So from here, we'll proceed. We'll do En1 first. We know that I1 plus IL plus I3 equals 0. From there, we'll substitute. I1 is going to be nothing more than the voltage of R1 divided by the resistance of R1, plus IL is the voltage of the load divided by the resistance of the load. And for I3, it'll be the voltage of R3 divided by the resistance of R3. Again, still all equals 0. Then from there, we'll substitute for our voltages. For VR1, it's going to be En1 minus ES1 all over R1, plus for the voltage of the load, En1 minus En2 divided by RL. And for VR3, it will be En1 over R3, and again, it's still all equal to 0. Any questions there about that? So from here, we can make our substitutions. ES1 is 12 volts, but it's negative terminal up, so it'll be negative 12 volts. Over R1, which is 1K, plus En1 minus En2 over RL, which is also 1K, plus En1 over R3, which is 3K, all equals 0. And from there, we can find a common denominator. Obviously, it would be 3K. In order to get 3K in each one, we'd have to multiply by 3 over 3 for this term, 3 over 3 for that term. Now we need to create a common denominator, which I'm not going to rewrite because when I cross multiply times 0, it's going to leave me with no denominator at all. I'll then distribute the 3. Well, first I'll take care of this negative times a negative is a positive. Distribute the 3, I get 3 En1 plus 36 plus 3 En1 minus 3 En2 plus En1 equals 0. I can combine like terms. 3En1 is 6 En1 plus En1 is 7 En1. And then I have minus 3 En2 And at positive 36, I'm going to move to the other side and make it negative. And there's our node 1 equation. For our node 2 equation, we will have I2 plus I4 minus, because that one is leaving the node, minus IL equals 0. From there, we'll make a substitution. Using Ohm's law, the current of I2 is equal to the voltage of R2 divided by the resistance of R2, plus that current of I4 is equal to the voltage of R4 divided by the resistance of R4, minus that current for IL is going to be the same as it was over there, EN1 minus EN2, or EN1 minus EN2, all divided by RL. And again, that's all still equal to 0. Why did I just write that there? Yeah, that should have been the voltage of RL. I skipped a step there. Now I'll substitute for my voltages. The voltage for R2 is going to be EN2 minus ES2, leaving me with the voltage of R2. So EN2 minus ES2, all again over R2, plus the voltage of R4 is going to be EN2 over R4. And lastly, minus the voltage of the load resistor, which is going to be EN1 minus EN2 all over the value of the load resistor, still all equal to 0. Now at this point I can plug my values in. EN2 minus a positive 24 volts divided by R2, which is 2K, plus EN2 over R4, which is 4K, minus EN1 minus EN2 all over RL, which is 1K, all still equal to 0. Now from here, I want to get the least common denominator to be able to combine them. That would be 4K. In order to get a 4K here, I need to multiply the top by 2, or 2 over 2. 4Ks aren't in the denominator there, I don't got to change anything. In order to get a 4K here, I have to multiply it by 4 over 4. Now at this point, I can rewrite the whole equation. I can also get rid of the denominators, because once I get a common denominator, it's going to simply cross multiply times 0, leaving me with 0. So I'll distribute first. I'll get 2 EN2 minus 48 plus EN2 minus negative 4 times EN1 is negative 4 EN1, then negative 4 times a negative EN2 is a positive 4 EN2, and again, it's all equal to 0 still. At that point, I can combine like terms. I've got 2 EN2, EN2, and 4 EN2, giving me 7 EN2. I've got negative 4 EN1, and then that negative 48, I'm going to pop to the other side, change its sign, make it positive 48. There's your node 2 equation. From there, you can use the elimination by addition method to solve for node 1 and node 2 voltages. Once you get that, then you can solve for your resistive values and then fill in what your current is. Any questions there? Okay, that concludes the review.